welcome to our series of videos on expanding and factorising. And today we're going to do expanding. If you haven't seen this video on the vocab of algebra, and if you don't know these words, then have a look at that video, because we'll be using some of these words, terms, binomial expression, all of these all the time. Okay, so what is expanding and factorising? What are we even talking about here? And I'll go through why this is important in a second, but firstly, what even are we talking about? Expanding is when you have two factors and you multiply them to get an expression. So going from here to here. And factorising is doing the opposite thing. Taking an expression and separating it into factors. So if you're wondering how an expression can have factors, let's just think about the number 6 first. That's not an expression, it's just a constant. But the number 6 has two factors. I've drawn a little factor tree here. The factors are 2 and 3. And also has two more factors, which are 1 and 6. But you can divide 6 by 1 or 2 or 3 or 6, and you can get a whole number. That's what factors are. So you can also take an expression like 2x plus 10 and divide it, and you can draw a factor tree here. And you can, if I divide it by 2, I get the other factor is x plus 5. And you might ask, how do I know that? Well, if I divide 2x by 2, that cancels out the 2. So I just have x. And if I divide 10 by 2, 10 divided by 2 is 5. So I have x plus 5. And so this is a factor, and that's also a factor. And you can see that there's no decimals or fractions in this. The only numbers here are 5, and this is like it has a coefficient of 1. So there's only whole numbers here, and that's why it's a factor. All right, and if you want to test that you've got the right factors, two numbers that are factors, then you can multiply the factors. So 2 times 3 equals 6. You've multiplied these two factors and found out that they are, well, you get 6 at the end. You can also test this one. 2 times x plus 5. If you multiply this by this, what you really have to do, and that's the whole expanding topic, you times 2 by x, so you get 2x, and you times 2 times 5, and you get 10. So, as expected, we get back to here. So if I go from here to here, that's factorising, separating it into the two factors. But if I go from here to here, that's expanding. All right. So here's this in our diagram. 2 times x plus 5 is equal to 2x plus 10. If I go from here to here, that's expanding. Here to here, that's factorising. And here are our two factors. And here is the expression. Okay, hopefully this is all making sense. We'll get into some examples pretty soon of expanding, but we've finally got to ask ourselves the question, why am I even doing this? And the answer is, you are doing this because it will help you to sketch all sorts of interesting graphs, like parabolas and cubics, and simplifying fractions in high school and university maths and science. This comes up all over the place. If you watch the linear graph series, you know that we had some real world problems, and we used linear straight line graphs to help us understand these problems from the real world. But the real world is a lot more complicated sometimes than straight lines. And that's why you need these other types of graphs to help you out. And this will help you draw the graphs, and it will also help you solve more complicated equations like this one, because again, in the real world, it is more complicated sometimes. And sometimes you have to solve these types of equations, see how there's a squared here. We've never done that before. Or you haven't, if you haven't learned this yet. And just an example of a parabola or the type of graph that we're using. Well, here we go. This is a parabola. It's just a hose with some water droplets, but they are moving in the shape of a parabola. So you can see how naturally this parabola occurs in the real world. And there's lots and lots of applications of parabolas and cubics. And this will help you to sketch them, and it will help you to solve the more complicated equations. All right, well, that was a long intro, but I think it's important to understand expanding as the opposite of factorizing and factorizing as the opposite of expanding, and understand how closely related these two things are. But let's get on to expanding. Now, expanding, as I said before, is taking two factors and getting one expression from that. Well, I mean, this example is sometimes you have three factors and you're getting one expression, or four factors and you're getting one expression, but let's just start simple. So here's my two factors. 4 is one factor and 2 plus 3 is another factor. And I'm going to show you by use of circle diagrams that all you have to do is multiply these two numbers, and then you multiply these two numbers, and your two answers that you get from that, you just add them together because it's added here. Just like this. So 4 times 2 and 4 times 3. And you add them together. And the reason I'm saying that is I've got 4 groups of 2 plus 3 circles. This is really 5, isn't it? 4 groups of 5 circles. 1, 2, 3, 4. And over here, you can see that when I separate them, it still makes sense. Here's 4 times 2 and 4 times 3. So that's my little visual proof for why expanding actually works. And now when you get to numbers, here's an example of how this works in terms of when I have an x in here instead of a number 2. It works the same way. So you've got 4 times x, which is 4x, plus 4 times 3 over here. And you simplify this one to, obviously you're not going to write that in your final answer, you're going to write 12. Okay. Now, I think, no, I didn't have, that was something else. Okay. Let's do some examples of expanding. Now, what I want you to do when you start off with, actually, red's not a bad idea, is draw a little line here to show that you're multiplying this by this. And draw another line here to show that you're planning to multiply this by this. Okay, so for the first line, 3x times x, so this whole thing is equal to 3x times x. What's x times x? That's x squared. And then I'm adding on 5 times 3 times x. So, all right, 5 times 3x. But for this one, you just multiply 5 by 3, that's 15. So you've got 3x squared plus 15x. And that's it. It's no more complicated than that. Now, this is when I've got a term times a binomial. But eventually you're going to have a binomial product, which is, this is a binomial, and that's a binomial. Remember, a binomial from our vocab section, binomial expression is just something with 2 terms. And a binomial product is 2 binomials times together. So sometimes you will have this, and you'll be asked to expand 2 binomials. Now, for this one, you have to multiply everything in here by everything in here. And this is what I want you to do. You can sometimes remember what I'm doing here by the acronym FOIL. Whoops. FOIL, which is first. So the first two terms. And the outer two terms outside. And then the inner. Then that's these two terms. And then the last two terms. And then you can ask yourself the question, have I multiplied every term in here by every term in here? So just take the 2, for example. Have I multiplied this 2 by everything in these brackets? Yes, I have. I multiplied it by the x, and I've multiplied it by the 3. Or at least I will. So now let's do that. So let's do the first ones. So x and x, that is x squared. All right. And then let's do the outer ones. So x times 3. Do I write that as x3? No, I don't. I write that as 3x because the coefficient always comes first. I've got the inner ones now, 2 times x. And now I've got the last ones. So that's 2 times 3, which is 6, of course. Now, the reason I'm writing equal sign here is because when you have a binomial expression, often you'll have some like terms. So if you look for like terms here, the like terms are the ones with the same variable. And now x squared is not a like term with 3x. That's because you can't just add up x squared with 3x. It doesn't simplify. You can't really do it. 3x and 2x though, that's like saying I've got 3 x's and then I've got 2 x's. So how many do I have in total? I've got 3 plus 2. So 3x plus 2x is 5x. So I can add up these like terms. So, and then the x squared just stays as it is. And the 6 just stays as it is. All right. Now, have we got any other ones? That's how to expand a binomial product, but we've got one more example. And this is when you've got a not trinomial, a product of 2 binomials and something else. Or you could even do a product of 3 binomials, but we'll just do this one. Now the trick with this one is you only do 2 at a time. So you only expand 2 factors at a time. So this is one factor, that's another factor, and this one, that's the third. Let's just expand these 2 big ones, and then finally we'll expand this one. So we'll just write the 2a at the start, and then we'll write some big brackets, and inside we'll put whatever we get for when we expand it. And I'll write the equal sign down here. Okay, just so I have room to do my lines. So I would like to do the first, outer, inner, last. I'll just get rid of these lines so they don't confuse you. All right. So let's write our 2a here, and then do the first, multiply the first 2. So 3b times 7a. Well, 3 times 7 is 21. And b and a, when you're timesing them together, you actually just you should write it in alphabetical order. So AB, which is the same as BA anyway. We just write it in alphabetical order because it's nicer. Then we have to do the outer. I might just write my little FOIL up here. So I've done first 2 terms, we'll do the outer. So 3b and 2. 3 times 2 is 6. So we've got 6b. The inner ones, so that's now, because I've got a negative here, I actually have to multiply -4 by 7a. So I'm subtracting here. Minus, that's 28. 4 times 7 is 28a. And then finally, so I've done first, outer, inner, I have to do the last 2 terms. -4 again times 2, that's -8. Now I'll do my closed bracket. So now I've actually expanded these 2 factors. And I've got one big expression here. And you can see, hopefully you can see there's actually no like terms here. Okay, now let's expand the final factor, which is 2a. So I have to multiply this by everything in here. Just drawing lines connecting everything here. Okay, so let's draw my little equal sign a little bit lower to make a bit of room. 2a times 21ab. Now, there's a lot here. You've just got to take it step by step. Look at the numbers, first of all. 2 times 21 is 42. Then look at the letters, and we'll start with the first letter in the alphabet, A. So A times A is A squared. Then we've just got a B. I'll write that B on there as well. Okay, now let's do the next one. 2A times 6B. 2 times 6, we'll just do the numbers first, is 12. And then we've got an A and we've got a B. Minus 2A times negative 28A. Well, I've already written the minus. So 2 times 28 is 56. Don't worry if you can't get these multiplications right. You can use a calculator if you need to, but as long as you understand what we're doing. So we've got A times A, which is A squared. And then finally we've got 2A times negative 8. That's minus. Let's look at the number. Well, there's just a number here. So 2 times 8 is 16. And then A times it by A. All right. That's it. That's a pretty difficult example of expanding. If that was really confusing, what I'd suggest is that you rewatch the video, but just watch the simple example and then pause it. Or just don't rewatch the whole video, just watch this simple example and then pause the video and try some questions with only, a term over here and an expression here. And then you can, once you're confident with this, you've checked your answers and everything, you can move on to a binomial product like this and start doing this whole FOIL thing. And finally, once you're confident with that, move on to the harder examples. All right, well done for getting to the end of that, and I'll see you next time when we start. We'll do a little bit of revision on expanding, and then we'll go to factorising.